I think it's only fair to say the theory is not exactly a scientific theory. It has more to do with the interpretation of science. It's not even a rival to science. It's analogous if you think of the scientist as the printer who works laboriously all day setting the type. What the theory is doing is to start to read the message that the type, what is the type saying? This has nothing to do with critiquing the laboratory experiments. It's getting the message. And in this respect, the layman is better off than the scientist. The scientist is totally concerned with getting the letters in the right place. He doesn't stand back and read what they're saying. Now this seems preposterous or too bumptious to purport that I can read something a scientist can't read, but he is bound to be myopic because he has his nose so close to the print. As Bacon said, you can't really get the significance of a science if you stand but on the same level of that science. You have to move to a higher level. That is one of the reasons we have to combine so many sciences together, because we're getting the threads that interconnect them. And they're not visible to the scientists within each discipline. Now, let me apply that a little. For example, physicists are very much embarrassed by talking about forces. They can't conceptualize a force. They go to great lengths to explain it somehow. One of the ways they try to explain the force is say that it's due to particles flying back and forth. Gravity is due to gravitons coming in. Well, they've never seen gravitons. There's no evidence of them at all. It's just something to be able to deal with something that's hard to conceptualize. Another is to say that space-time is bent. Well, space-time is a fantasy anyway, and if you want to bend this fantasy to account for something, you're really in desperate straits. People understand forces much more directly. It's even more fundamental than things. They have to exert forces all the time, stand up. A baby is afraid of falling. That's acceleration. It's the basis of force. Well, in any case, forces are part of cosmology. And we're expanding the vocabulary, expanding the language to include forces. And when we start reading the message, we find that forces in nature are analogous to forces in our own lives. What's attraction? Attraction, well, when you boil it right down to it, what else can you say? The way I feel about my girl, I'm attracted to her. You can't describe it in any other words. Now, when it comes to purpose, there is no word for purpose in science, but here is a finding of science that has precisely the qualifications that fit it to purpose. A dynamic that pushes things along, that causes things to change, that changes the state of other things. So the cosmology broadens, and the vocabulary is broadened too, but actually it becomes more economical because you can talk about people and physics with the same words. Thus the atom, first thing to have identity in physics, has a correspondence to the immune system in the person. It's the first way we identify, the system is able to have an identity. the accuracy of atoms in identifying just the right frequencies is 1 part in about 10 billion. This corresponds to the immune system, which can reject an organ from another person, any other person among the 4 billion inhabitants. How is it possible? When you get these impossible things, the only way is to say, well, that's the same impossibility I had with atoms. And you narrow down the number of impossibles, and then you begin to see their interconnection.